Bismillahirrahmanirrahim. We continue our discussion in software engineering. On further more topics in the software process. The points that we had already discussed was, first we defined the software process. What is the software process in previous lecture? And we said it is basically a sequence of or a collection of steps in order to develop a high quality software. So the framework of activities is generally known as a software process. Every process may not be suitable for every software project. That means a single software process may not be suitable to every software project, but there are some of the basic steps that are common to every software project, which we have already discussed in previous chapter. Then we defined what is software engineering and what are the basic components that form the software engineering. So software engineering, the main intention of developing a software product is to have a high quality output. So in order to have a high quality product, you need to have sound software process, good software development methods, and technically sound tools need to be used to develop the end product. Then we discussed different generic phases in software engineering. These are the phases within the software process which we just said are common to every software project. That includes the definition phase, in which you have to answer all the whats, and then the development phase where you need to answer all the hows. And then we need to provide the support or maintenance phase. Different type of supports services are provided, which we had discussed in detail in previous lecture. Then we discussed different software maturity levels. These are the levels, maturity levels for the software process. So if you need to identify or if you need to judge the maturity of software development organization, you can level them or you can judge them on the basis of these maturity levels. 5 different software process maturity levels have been discussed in previous lectures. In today's discussion, we are going to discuss different software process models. These are the models on the basis of which a software is developed. They are used within the software engineering. Every process model has basic steps that we discussed in the generic phases in software engineering. Those basic phases are followed in every software development process model. But the mechanism to follow them, the duration to follow them varies in different models. So we'll be discussing different models in this lecture. In today's discussion, we are going to discuss the software process models. What is a software process model and what different types of models are there? This is the topic of discussion in today's lecture. So let's see what is a process model actually, and then we will discuss one by one these different types of models. We have these different models. Some more are also there which you can study if you are interested, but these are the common models that we'll be discussing. So let's see what is actually a process model. In order to solve problems for some customer and the solution necessarily be a software, if you are sure that the solution must be a software solution. So the software engineer and his team needs to incorporate a development strategy consisting of process, methods, and tools. These are the framework of software engineering. So when you are sure that the solution to your customer problem is a software solution, so you need to develop a software using proper process, methods, and appropriate tools. So we have already discussed these three components previously, as they form the layered components for software engineering in order to develop a quality software. So this development strategy is known as a process model. The strategy that you develop using these three components is known as the process model. A model is generally selected on the basis of nature of project and its applications where it will be used, the methods and tools that are selected to be used to develop that product, and the controls as well as the generated end product. So these are different factors on the basis of which a specific model is selected for some project. As we have seen in the outline, there are different models. So what model is suitable for your project? That is generally selected on the basis of the nature of the software that you are going to develop and where it will be used. And then the methods and tools that you select to develop the software product, and also what type of the product you need. Software engineering steps can be equated to problem-solving loop mainly, where there are four main phases. Here you can see I have drawn a generic model, generic software process model that we had already discussed in previous chapter. So the steps that you generally use to develop a software in order to solve a problem works in a loop. The first step is the definition loop. The definition step. In definition, which is also known as problem definition, we have discussed this in detail in previous lecture, in which you have to answer all what's. Then the next phase is technical development, or simply development. Then after developing the solution, we integrate the solution in our system, in our environment, and at the end we perform the support services, the maintenance, or check the status quo. So these four steps form a loop. You need to go through this loop again and again if required. Problem definition represents the particular problem that is required to be solved by answering all what's. We had discussed that. The technical development solves the problem by applying some technology, and the solution integration represents the delivery of product, not only software but also all its related documents that we defined what a software is in chapter 1. It's not only the software but also the procedures, the related documents that collectively form a software. And then you provide the maintenance services, or customer feedback is provided in order to continuously improve this loop. Your softwares vary in nature. That can be some client-server application or some peer-to-peer application or some standalone application. So your software provides different applications depending on the nature of the product. Now, after understanding what a model is, we need to now discuss different software process development models. And the first model that we are going to discuss is the waterfall model. What is waterfall model and where it can be applied? Let's proceed with its details. Waterfall model is also known as linear sequential model or classic life cycle model, and this is the first model developed for software engineering in order to develop a software. So it can also be known as linear sequential model or classic life cycle model, as it represents the sequential approach to software development. So this is, here you can see the sequence of different steps are followed in order to develop a software, and the first step that starts is the requirement analysis until the support or maintenance. This is the first model introduced, and it requires a previous stage or previous phase to be locked before moving to next phase. And this is why it is known as waterfall model. As the name suggests, waterfall, the water falls in forward direction. It cannot move back. Similarly, when you move forward from one phase to another phase, such as you have moved from requirement analysis to design, then you cannot go back to requirement analysis again. So in this model, the previous stage or the previous phase gets locked. Similarly, as waterfall falls in forward direction, it cannot go back. So this model, the steps move forward, you cannot go back. What is requirement analysis? We will be discussing these phases in details, chapter-wise, in the coming lectures, but briefly I want to explain what actually requirement analysis is. It is the phase where requirements are not only collected, rather they are analyzed in order to focus on the solution required. The requirements are properly documented and reviewed with customer before they are finalized. So it is sort of a paperwork. The next step is the design step, or next phase is, second phase is the design phase. It is a multi-step process focusing on 4 different attributes of your software, such as designing data structures for the software, designing software architecture, designing interface for your software and algorithms, along with the procedural details. So it is not only designing the architecture, rather we design different components for the project, such as the algorithms are designed, data structures are designed, interfaces are designed in this phase. So it is a multi-step phase. Design translates the requirements to a map or an architecture, and then that map is assessed for quality before the coding begins on it. Now the next step or the next phase is the code phase. The design is then converted to machine readable code. If detailed design has been generated, so coding becomes quite comfortable job for the programmers. Next important phase is the testing phase. It is quite time consuming phase and very important phase. We can also call it a destructive phase. Once code is generated, testing of code then begins. Testing is done for both the internal logic of code. You need to check the internal logic. Every line of code is tested, and also testing is done in order to check the behavior of software. So both the internal testing and external testing needs to be Then which we call black box testing and white box testing, and we'll be discussing that in detail when we will discuss the testing chapter. Testing is done to uncover errors and to ensure that the defined input will generate the desired output. What output is required? For that you need to give the defined input. So testing mainly uncovers the errors. And last step is the support phase or the maintenance phase. We had already discussed this quite in detail in previous lecture. Different types of maintenance or support is provided, and support is mainly provided if there is some change being incorporated in the system and system is not properly functioning the way it was functioning before the change came in. So you need to provide that support to your system in order the software to be functioning as it was expected. Now, what are the benefits or advantages that waterfall model delivers? This is quite an early model and very simple to implement. It doesn't take care the risk factor. Very simple, but it is quite time consuming. You need to, since its different phases are blocked when you move forward, so you need to spend enough time in every phase in order to clear all the doubts. So this is the first model introduced, so it is quite simple to follow. The next benefit that it provides is that it generates documents at every stage, which makes the software design very understandable. So you need to develop, produce, generate documents in every phase, in all the 5 phases. You need to generate the documents, which will help the people working in other level down to justify their work, to justify the logic that has been brought forward from the previous phase. Next benefit that it provides is here the requirements are very well understood, and you develop what you understand. Since you spend quite a lot of time in every phase, the requirement analysis has main impact on the end product. So here you remain in constant communication with the customer, tries to refine his demands, his requirements in order to properly understand them, so that whatever is in his mind is actually developed as the software product. But there are some disadvantages related to waterfall model. The first disadvantage, as we just said, that it locks every phase. When you move forward to next phase, the previous phase gets locked. So that means if there is some error that has been propagated to next phase from the previous phase, so that error cannot be rectified by moving back to that step, and the error will propagate till the software develops. So this is the very common drawback in waterfall model, that every phase gets locked. So error can be easily propagated from one phase to another, as you cannot go back and rectify the error. Next disadvantage is that until the whole software is developed, you are not able to see the product. So it may take quite a long time to develop the product. There is no working or immediate or first version of software is available by this model. You need to wait to see the complete working software, and it may take quite long. Another disadvantage, it can bring uncertainty, because whatever is understood is generally developed. since you cannot go back, cannot discuss again with your customer if you have not properly understood the requirements. So there may be some sort of or some level of uncertainty in every phase. You may be confused whatever you are developing is what is required or not. So if you are confused about some product, you are not suggested to use this model. Now, when to use it? You are supposed to use this product only when the requirements are quite clearly understood. Otherwise, it is going to be very complicated to handle your project. If you properly understand the technology that you want to use in the product, in this project, only then you can use Waterfall Model. Waterfall Model is very well suited for developing some new version of existing product, because a product has already been developed, the requirements are understood already, design has been already developed. So when you are to develop some new version of that product, so the best suitable model then in that case will be the Waterfall Model. So this is all about the Waterfall Model. I hope you have understood what Waterfall is, how it works. Now the next model that we are going to discuss is the prototyping model. Prototype model is our second model that we are going to have a detailed discussion next. Sometimes customer is able to define few requirements and is not sure about the detailed input or output requirements, while even the software engineer may not be at times sure about the types of programming tools, the type of operating system to be used to develop some software. So there may be some level of confusion at both the ends. Maybe at the customer end, he or she is not sure about what he wants actually, and the developer is also not sure what sort of technology, what methods, what tools should be used to develop some project. So in that case, prototyping model is considered more suitable. So when you have some level of uncertainty, the better model, the most suitable model is the prototype model. It begins by collecting basic requirements, and a quick design is prepared out of those basic requirements and with the proper consultation with your customer. A quick prototype, we can also call prototype as a sample or first working software, gets developed out of the quick design. So you can see generally before delivering the final product, we need to develop a sample working prototype. So after collecting initial requirements, we generally develop a quick design out of whatever requirements we get, and then after quick design, a sample software is developed on the basis of the basic requirements that you have acquired from your customer. This prototype is then shown to the customer. Customer performs evaluation of the prototype, and then this prototype is used to refine the requirements by the customer. So here customer then brings changes to his requirements, suggests more features, suggests some of the features which are not required to be eliminated. So here this is a loop then. The prototype gets refined, the requirements get refined, and the developer also here enhances his understanding with the problem. Customer is also developing understanding with what he wants, and the developer is also developing his own understanding with the product or the project that he is working on. And at the end, a final product is delivered, which is then implemented, and then the support services are provided. Prototyping model comes in two flavors. First type is throwaway prototype. In throwaway prototyping, when a prototype is developed and evaluated by the customer, after refining the requirements, that prototype is then discarded and a new working software is developed again right from the scratch. While in case of the evolutionary prototype, the prototype is developed, evaluated by customer, and requirements are refined. So the changes are then incorporated in the same prototype instead of developing the whole software right from the scratch again. So working software is obtained by consistent or constant changes within that prototype. So it is known as the evolutionary. You need not to work again for developing the functions you have already developed for the prototype. So your prototype gets refined with the passage of time, with the evaluation by customer, and that prototype then ultimately gets converted to the final working software. Now, what are the advantages of using this model? The best advantage or the main benefit that it provides is that you get a working model quite early. You have basic requirements, you develop some working software on the basis of those requirements. So working software is, or first version of the software is available quite early, and then you refine your requirements. Another benefit is that the developer also gains experience and insight by developing different prototypes. He may not be clear right from the start what he has to develop, what sort of tools, what technologies you had to use for the project. So he gains experience by working on different prototypes. He would change the technology if one is not suitable while developing a prototype. So in order to develop another prototype, he may change the technology, the tools. So in this way, he gains experience. Another benefit is that this model is best to reduce the risk. It is the most suitable model to have clear understanding when prototypes are developed, so the risk associated in every phase gets reduced. So the margin of errors becomes very less when you ultimately get a working software. Another benefit is that prototype helps in clarifying the user requirements. A user may not be sure what he wants in the beginning of the project, but with the passage of time, when he sees a working sample of what he wants, he then gets cleared about what sort of software he actually needs. So it is not only providing an opportunity for the developer to gain experience, but also for the customer to refine what actually he wants. But it also has some disadvantages. For example, when you develop a prototype, and we develop softwares for generally layman, so the user may think this is the final product and he may not be satisfied with it. So then the developer has to make him understand that this is a working sample, it is not the end product actually. Whatever we have obtained as requirements, we have developed a working sample out of it. So you need to then clarify it to the customer. So a misunderstanding sort of may happen between the developer and the customer. Customer may consider it the final product and he may not be satisfied with it. Then false expectations may be obtained while working in prototyping model. Customer may expect a different thing while the developed product may work differently. So that is why prototype model is used in order to reduce the uncertainty. If you think something very high or something that is not be able to be developed, so if you think something out of the requirements, out of the context to be developed, so this model is not suitable there, because some requirements are those requirements which we generally are not able to speak them out, as they are generally understood that this thing must be present. So customer normally may not speak about it then. So here they develop some expectations which are, if not fulfilled, they may then reject the project. But here cost is quite high, as cost is incurred on developing different prototypes, and prototype may not be only single, it may require to develop multiple prototypes. The more requirements are refined, the more prototypes are built. So cost is quite high on prototyping model as compared to waterfall model. After discussing waterfall model, the next model that we are going to discuss is the RAD model, Rapid Application Development Model. Rapid Application Development Model, or RAD model, is incremental software development process model in which the software is developed in increments that emphasizes on short development cycles. So it is basically the adoption of waterfall model in which you intend to develop the software in short span of time. So we can say it is the fast speed adaptation of the waterfall model. It can only be applied if project requirements are very well understood. Generally, within 60 to 90 days or within 3 months' time, a software gets developed. Based on model phases, this model is based on model phases. Every phase is termed as a modeling or a model. So it is based on model phases. The first phase is known as business modeling. Now, what is business modeling? Here the business model or the business model is the phase where business functions or the software functions are properly understood. For example, the software engineer needs to answer questions such as what information is required for different functions, what information needs to be generated for different functions, what and who would generate those information, where the information would go. This is actually the requirements or the working mechanism of an organization or some business. So how the business is working, all the information is collected from the business. The next phase, which we refer as model, is known as the data model. Here the information obtained and refined from the previous stage, which is the business modeling, is transformed to data objects. So now the information which has been obtained in the previous phase is then converted to data objects. They are required to support the business. So those objects or those data objects are defined, which will then help to define your complete system. The attributes of all data objects are identified here, and the relationship among these objects are defined. It is more sort of the database you develop. You design a table, you design different attributes of a table, and the relationship among different tables, different objects are defined in this second phase. Now the third phase is known as the process model. The data objects defined in the previous phase are now transformed or modeled to achieve the information flow necessary to implement the business solution. So here you need to have a proper process in place where you convert the data objects obtained in previous phase into some practical solution. Next phase is the application generation, which is actually the coding phase. So rapid application development model uses or mainly relies on the reusable components to construct the software, and relies on using the fourth generation programming techniques, which encourages the use of reusable software components. The last phase is the testing phase and the support phase, which we term as the testing and turnover. Since the reusable components are used to develop software, that means the components have already been tested by some developer in previous or other projects. So this reduces the overall testing cost and time. But the new components that are developed needs to be properly tested. So here in RAD model, work progresses having no proper plan. Less attention is given to design a proper plan before you proceed to develop a project or a product. So the lack of planning, which can be a disadvantage in this model. Whatever you get as requirement, you start extracting rather information out of those requirements and start developing your objects. Now, what are the benefits that it brings? If you use RAD model, you will have a flexible and adaptable software. That means this model is quite flexible. If you want to bring in some change to your product, since this is an incremental model, as we just said, the software is developed in increments, increment by increment, or we can say increment as a sample product or a prototype. So if you want to bring some change in first increment, so that change is then incorporated in the next increment. So here it reduces the overall project risk. The overall risk associated with every phase gets reduced increment by increment when you get a working product that is more what was required by the business. Since this product depends on short development cycle, as we just said, maximum the time of development is 3 months, 60 to 90 days. So user can see the product quite early, irrespective of the other models which take quite a lot of time, such as the waterfall model. Waterfall model takes quite a lot of time. So here, since the maximum duration is 3 months, 60 to 90 days, so customer can see its product quite early. But there are some disadvantages associated with this model, such as it requires highly skilled and trained professionals, the one who can understand how to extract business information out of a business, the one who understands how to develop data objects out of those business information. So the trainees or the newcomers are not suitable to work on RADMO projects. Another disadvantage is that due to rapid development, since we require a software to be developed in quick span of time, the product may lose overall quality. The more focus is on development instead of the quality. So the quality of software may not be that good as compared to the products developed by the waterfall model, since the more focus is on the development instead of having quality in the end product. Another disadvantage is that it cannot be used for the projects having technical high risk. If you are not sure about the technology components that are more appropriate for the project, since you need to develop the project quite early, in quick or early span of time or short span of time. So if you are not understood or if you are not sure about the technology components, the tools that are appropriate for the project, so do not attempt to use RAD model on such projects. Otherwise, it would be hard to incorporate those technological components, those tools, the technologies that you have used for first increment to be adopted in the second increment. So if you are not sure about the technical feasibility on some project, RAD model is not suitable for those projects. The next model after RAD model now we are going to discuss is the incremental model. What is incremental model? Let's proceed with its discussion. Incremental model is now evolutionary software development model. The two models that we will be discussing now are the incremental model and the next model. They are mainly the evolutionary software development process models. They can also be known as the evolutionary software process development models. As the software gets mature in increments or releases, here again similarly as we did in the RAD model, we develop softwares in different increments. It combines the characteristics of linear sequential model, which we said was the waterfall model, and the features or characteristics of the prototyping model. So it has the characteristics of both waterfall and prototyping model. Software is divided or developed in builds. That means we divide the requirements in different builds. Builds means one increment. And every build adds features to the previous build. Similarly, the way we do in prototype. We develop a prototype, get it evaluated from the customer, refine the requirements and develop another prototype. Similarly, whatever we get the requirements, we develop an increment out of them. Then after evaluation, we add more features, add more functions, refine the requirements and build another increment or have a second build. First product or first core build is developed, which is evaluated by the customer, and upon his recommendation, a change plan is then developed for the next increment or next build. So user requirements get divided in builds by builds. You can have more builds as well. Build is similar to increment. One build, first increment, first working product. So first build is generally known as the core product, which gets then refined with the passage of time. This process continues. This process means this development of increments goes on until a complete software is finalized or developed. The difference between prototype and incremental model is that incremental model generates a working software after every build, while prototype is just a sample. You cannot make it or you cannot implement it in the customer environment. While the incremental, the first model, the incremental model, the first build or the first increment is a totally working software which can be implemented or integrated in the customer working environment. This model is particularly helpful in situations where the staff is not enough to work on project at once. When you have scarcity of staff, so you can work in groups. You can work, a small group can work on small piece of requirements and develop an increment. Then requirements get refined and some more features are added to that increment. So in this way a product gets enhanced and a final working product is developed. But keep in mind, every increment is a working software. That increment is implemented or can be integrated in the environment of customer. This process or this model has some advantages. For example, working software is generated quite early, similar to prototyping model. It generates software quite quickly in shape of increments or builds, and that is a total working software. It is quite flexible and less costly as compared to prototype, because in prototype we generally either throw away the prototype or bring changes in that working software, which is quite costly as compared to this incremental. But here the working prototype is considered as a complete software or the initial or the core product, and then the changes is brought in them, and later on we develop a complete software. So there is no throwaway concept in incremental model. So here it is as compared to prototype. Prototype was costly as we had to develop prototype. Prototype was just for the gaining experience both for the customer and the developer. So that was quite costly, but this is less costly as we enhance the increments in order to develop the final product. And it is quite easier as you have to test very less. The less you test, the easier it is to test. So if you get one feature or one function added to the software, you need to only test that specific function, not the whole software. So it is easier to test. So generally the softwares that you use in today, they are developed on incremental basis. You get updates of those software. That means new features have been added to the previous one. That means they are being developed on using incremental model. But there are some disadvantages associated to this model. Here you need to have proper planning and monitoring. You need to have develop proper plan right in place, because you are going to develop the core product, which is a working software. It has to be integrated in the business solution. So in order to develop a core product which may have some basic functions, you need to have proper plan and proper monitoring of how those requirements have been converted to software or a core product. And then you need to clear the requirements right at the beginning. If you have two requirements, that should be clearly understood to you, or the core product will go wrong. The total cost as compared to the other incremental model that we are going to discuss next is higher. The spiral model, that is next model, as we just said, in the benefit it is less costly as compared to prototyping model, but when we discuss the evolutionary models, so it is little bit higher in cost as compared to the other evolutionary model, which is spiral model, because here you do not have a complete team to work on the complete project. So you need to hire professionals, you need to hire trained development team to work on different increments. So the overall cost may then go high. The next model that we are going to discuss is the spiral model. The last model, there are some other models which you can study, but this is the last model of evolutionary software development process models. So spiral model is another evolutionary software development model, similarly that we discussed the incremental model earlier, and it also combines the characteristics of waterfall and prototyping model. So this is an evolutionary software development process model that we just discussed for the incremental model. So it combines the features of prototyping and waterfall. It has the capability to first develop of incremental versions of software. So spiral model also focuses on increments, the way we discussed for incremental model. The diagram for spiral model is in shape of a spiral. Here you can see a spiral in the diagram. This is sort of a coil spiral. So you can see the diagram as a coil or a spiral which is divided in different regions. You can see we have divided it in different working regions. You can see here first region, second region, and you can divide it in different working regions. Every region is then divided in separate or independent activities. For example, first region is the planning region. So in project planning, in which a complete plan is developed for the time, how much time will be required to develop a specific build or specific increment, what resources will be required to develop a build, and other related information. So a proper plan is developed for different resources, the cost on different resources, the time to develop an increment or a phase. Another activity or another region, we call it as risk analysis and resolution. And this is the only model which properly takes into consideration the risk factor. So spiral model is the only model that we have discussed so far that considers risk as an activity, risk evaluation or risk resolution as an activity. No other model gives any attention to risk factor. So here both the technical and management risks are considered and solutions are pre-planned before the work actually begins. Next region is the engineering region. So this is an activity in which the core product is developed, and the last phase, core product developed means design is developed and the code is then developed for it, and the last phase is the evaluation by the customer, which means the feedback from the customer is obtained in order to refine the first core product. When the requirements are refined, again a plan is built for the second increment or for the second product. Again risk resolution is done for the plan. The second build is engineered again evaluated by the customer, and in this way the coils increases in size. So initially it was a minor project, and slowly and gradually the size of the project, here you can see, goes on increasing by increment by increment. So initially small requirements, and then requirements goes on getting refined, and a higher or a complete project or a complete software is then developed. There are some benefits to spiral model. For example, changing requirements can be very easily accommodated in so this is the model such as we used in waterfall, we have used in prototyping, that you can, after refining the requirements through evaluation by the customer, you can change the requirements, you can refine your needs, and then in another build you can have those changed requirements in shape of another software. Another benefit is it uses extensive use of prototype. You need to develop prototype after every spiral. So a lot of prototypes may be developed in this model before delivering a final working software. User can see the system quite early in shape of prototypes. You can have your basic requirements, get them developed as software, so you can see a working software quite early in software development lifecycle. But here frequent customer feedback is required. That means customer communication with the developer must be in place quite consistently. If customer goes out of sight or out of communication, so then there may be the chance that whatever is understood by the developer, whatever requirements he understands, he develops the product as it is, which can be then troublesome for the customer later on when he evaluates the software. But there are some disadvantages also, such as the end of project may not be known. The time duration is not fixed when the complete software will be developed. So it is quite hard to reach to the end, or you cannot estimate the time the overall project will take to complete. And then it is not suitable for every project. If the time is not fixed, so this project or this model is not suitable for every project. If you have time constraints, you can go for other models that we have already discussed. It is quite complex process, since risk resolution is not a minor activity and you need to have expertise to evaluate risk in every phase of software development. So this is quite complicated. And secondly, you need to keep resources aside for the risk. Risk is something which may happen, it may not happen, it may happen during software development. So you need to keep aside some resources in shape of the tools, in shape of the manpower, in shape of time, in shape of cost and other related things in place in order to handle the risk if it arrives. So this makes the whole development process quite complicated. So risk assessment expertise is required. So you need to have experts who are quite capable to handle any sort of risk that may arise in software development process, in overall software development process. So you need to have the experts in place. That is all for now. This is the end of this chapter, the software process. This is the second chapter that we have discussed in software engineering. In today's discussion, we discussed different software development models that include the Waterfall model, the prototype model, the rapid application development model, the RAD model, the spiral model. So different, and the incremental model, the different models have been discussed in details along with its benefits and the drawbacks that they bring along. I hope the topic must be understood to you. If you have any queries, you can email me or ask me on KCMS. From next chapter will be started in the next lecture. That is all. I thank you all.